Okay, we will start the session. Today we are going to discuss similarity calculation method in text mining. Text mining in the sense, let's think about an article. You are getting an article or you are getting a paper. That paper contains some paragraphs without title. So whenever you are reading that paragraphs, you can understand which related article, isn't it? To have that much of ability, let's say whenever you are picking a paper and on that paper there are 2 to 3 paragraphs. Then whenever you go through the paragraphs you can understand which related those things. How you can find out which related this article is? Even you don't have any title for that article, just 2 to 3 paragraphs. Whenever you are reading that paragraph you can understand which related article is this. How you can find out? Someone tell me, what is the way you can find out this is related to political news, or this is related to sports, or this is related to weather data? How you will find out? I think you all are able to find out. Am I correct? Once I provide an article without a title, you can tell me this related article is related to sports or related to local news or related to business. You can find out, no, which related, or you can't find. Tell me someone. Once I give an article, do you have the ability to find out which related article? Someone tell me. Just asking the simple questions. Whenever you are going on the road, you are getting some paper. Whenever you are read that paper or whenever go through the paper, you can find out which related things they are mentioning. Don't you have that ability? Tell me, do you have that ability? Just talk, otherwise it's very difficult. Just I don't understand whether you can get my point or not. That's why I'm asking you. Tell me. Just I bring a A4 size paper without the title. Just that paper contain 2 or 3 paragraphs, and I instruct you to read the paragraph. Tell me which related article is this. You can or you can't.
We can, sir.
How you can? Whenever you go through the paragraphs, how you can find out this is related to sports, this is related to political, this is related to international news, or this is related to weather, this is related to business advertisement? How you can find out those things? You are using your senses, and you will, whenever you are go through that paragraphs, you know whether if it is whether if it is a sports related article, they that paragraphs contain some specific words, no? Based on these words you can find out, okay, this is related to sports. Even if you can go inside and you can say whether it's football related articles or cricket related articles, or whether it's related to soccer, or whether it's related to olympic. Likewise you can even go inside based on the words they have, isn't it? So that thing we are discussing here, we are trying to discussing in related to Texas. Up to now, we are discussing some numeric data. Now we are doing the similarity calculations method in Texas, where you can find out Texas. Lot of web pages they are containing Texas. There are blockers, or there are a lot of web pages. The content of the web page is in text format. Also, the newspaper articles they contain text. Where else you can find Texas? Whenever you are go through the social medias, most of the posts are there. The comments all are text. Sometimes whenever you are purchasing something in the online, you need to provide some comments or reviews. Those are mostly text comments. Whenever you are using the Twitter, you are using other different social medias, you are most of the time you are using texts. So what we are trying to do here is based on the texts, we will find out which kind of comment is this. Is it good comments or bad comments? Or is it criticize someone? Or all the things we are done by using the text mining. That is the content what we are discussing today. Okay, whenever you are go through the session, you will differentiate the synthetic similarities and semantic similarities. Synthetic similarities mean they have the same structure. Many words have same structure, but if it is a semantic similarities, they have similar meanings related things. Did you heard about synonyms? If you think about synonyms, they have same meanings. That is called semantic similarities. We are after we will continue or we will finish the session. You can distinguish these two similarities, whether it's a synthetic similarities or semantic similarities. Also, you can elaborate or explain, or you can demonstrate the types of similarities methods are there. What are the different similarities methods we have? Those things you can understand whenever you fully collaborate with me throughout the session. Okay. I already told you each and everywhere we have text data sets. Also, the text data cover all kinds of topics. Am I correct? Whenever you look at the newspaper, you can find out related to people. There are a lot of articles are there related to the famous people, whether the president of different countries or the sportsmen who achieve something in the present world, or whether they are elaborate or they are give some information related to the people who achieve something. Am I correct? Just think about the newspaper. They have a lot of events are there. They are describe the events. Even recently in our university, we have do a international symposium. So that's an event. That event details are published in the newspapers. Similarly, whenever you look at the newspaper, you can find out the information about different products. Even they are do some marketing related to their products, whether it's a electronic product or a lot of products they are marketing throughout the newspaper. They are elaborating the features of that products. Even you can view some features of laptops and the prices, what are the specifications they have, everything you can look at. Also, you can look at some services whenever you need some services. Let's say you need some tutors for for O-level students or the A-level students, you can easily pick up the services. Even you can find out some decoration services or lot of services are there. So everything in the newspaper described by using texts. Even they are described by some images, but they definitely put some texts. So texts are there in each and everywhere. Each and every topic we have some articles. Let's think about the internet. Whenever you are using a search engine or Google search engine or Google browser, what we are doing, whenever you are enter some keywords, they will give you some results. How they will give you the results? One important thing is all the results they are giving you in the priority is fully related to the keywords. How they will find out? By using text mining. Already they are done some techniques related to those articles, and they will categorize the entire web content. Whenever someone is entering that keyword, they will provide the results. That is the way they are doing. Also, you can find the texts in different places. There are many people are writing blogs. Anyone you are writing a blogs in your bench? As a IT students, you can write some blogs related to the printing technologies, or you can do some blogs related to cloud computing, whatever you are interesting or you have enough knowledge or you are expertise in the field, you can do some blogs. It's very helpful for others. Whenever someone is go through the blogs, they will get some knowledge. So whenever you are writing a blog, you are creating some text data. Even there are a lot of forums are there. In the forums, you are discussing different topics. At the time, most of the time, you are using texts, even reviews, comments, each and everywhere you are using texts. So it's very, very important here is how you can classify the texts, which related, how you can categorize the texts. Let's think about the research articles in the online. They have 5 to 10,000 words are there each document. So it's very difficult to read the entire document. So whenever we have some good data mining or text mining this system, where we can insert that particular research paper and we will categorize those research papers into different types. Even let's think about the source code. Whenever you are writing a program, you write source codes, codings. All the codings are different formats. So if you have a good text mining system, you can categorize your codes based on their features, whether it's related to backend codes or front-end design codes, or whether it's apply for this type of design patterns. You can categorize. How you can categorize? By analyzing the content of that documents or texts. That is the way you can find out. The important thing is each and everywhere we have texts. So the important problem we are facing here, how you can categorize, how you can find out the summary of the text. That is very, very important. For that, we are doing similarities calculation methods. Whenever you are look at the article, someone says he can ability to find out the article is related to this category. So similar thing we are doing by computationally. By using our computers, we are categorize the documents or the articles. It's related to this one or this one. Likewise, we are doing. Do you have any doubts up to now? Even any disaster happens, it will, let's think about now what will happen if any disaster happen. Anyone post in their Twitter pages or any social media. So we at the time we are getting some images and texts. So while analyzing the texts, we can verify whether it's a true event or not. Only one person is posting this kind of text. We cannot ensure whether it's true or not. But what will happen? Most of the people are writing a post related to this type of disaster. Then we can go for a final decision. Okay, this is happening now or something. Then we can confirm those events or disasters. For everything, we need to find out or we need to classify the texts based on their similarities. Just go through this example. In the real world, if you think about the real world, we have some sensors. By using that sense, we to sense that real world observation, we use some sensors, and that sensors report use that report contains some data. Let's think about today the weather is hot. How you can find out the weather is hot? Your skin has the ability to sense the temperature. Similarly, whenever you are using a thermometer, that is a sensor. That sensor sends the weather conditions. Then it will report. The thermometer reports the what is the temperature in Celsius. Similar thing happening in our body. Our skin sense how hot the weather is today or how cold the weather is now. Just think about some geosensors. Do you heard about GPS? Did you heard about GPS systems? They are tracking your location by with the help of satellites. So similarly, the geosensors used to find out the location where we are now in the world map, where we are now. It's find out by using geosensors. How it will happen? Let's think about this is the Earth. Here there is a satellite is there. So this is the point the person is there. Now he, he will find out the distance from him and the satellites. Likewise, there are a lot of satellites are there. This is also satellite. Then again, we are communicating with them also. Then we can find out the exact location where he is. Likewise, what will happen? We are using different sensors. Someone tell me an example of other sensors. In the weather reports, they are saying the speed of the wind is today is 10 kilometers or 50 kilometers per hour. How they will find out? They are using some sensors. That sensors sends the information related to the speed of the wind. Similarly, as a human, we have some senses. Whenever someone is provide a food for you, by look at the food or by taste the food, you tell me it's a good or bad. Am I correct? If it is a good food, your expression is happy. You express with your face as a happy. If the food is bad, you are expressed with angry or sad. Am I correct?
Yes,
Let's
sir.
think about you are going for a restaurant and you are ordering a meals. After taste the meal, you give some reviews whether this meals is good or bad. Based when let's say there is a restaurant called A, they have some facilities. After you are take the foods, you need to provide a review reports. Review means they will provide a paper, you need to write something. So what will happen? So a person A goes to there and he is sorry, he's not like their meals. It's not tasty. So he will write something about that meals. A person B goes to there and he likes their meals. So he likes something review. Whenever they are look at these two reviews, they will find out whether it's a good or bad meals based on their perspectives. So how they will find out this is good? Whenever someone express his idea, he will use some words or some sentences that helps them to find out whether they are satisfied with that food or not. Similar thing happening whenever you are purchasing something through internet or whenever you are purchasing or whenever you go for a supermarket and purchasing something everywhere you can express similar thing sorry similar things expressed by the sensors. Sensor uses some devices to sense the information. Similarly, human can have the capabilities to express or they can have ability to characterize something. Whenever you look at the image, someone is going for a restaurant and by using his human sensor, he will find out whether this location is good for families, whether their meals are very good in taste, very healthy. Everything you as a human you can find out. Am I correct? Then someone is asking you, you will express. Even you can orally tell me, I didn't like their foods. This is very good, very less taste, or they are not following the hygienic procedures whenever they are prepare the meals. Likewise, you will describe based on their your expression or your description, that person find out whether he need to go for the supermarket or not. If it is a numeric data, you put 1 or 0. Let's think about a supermarket give you a questionnaire after the meals. Just give marks 1 to 10. Whenever you call for a customer care, definitely they will give you a message after the customer care support service. Please marks 1 to 10. So if it is a 1, it's a bad. If it is a 10, very good. They accept their service. So it's a numeric data. You can easily find out based on the number. Just similarly, one service provider provide a white sheet to express or to write something related their service, your acceptance or not. So it's very difficult. Rather than we are getting the only single values, it's very difficult to find out from the texts or from the paper or from the documents. You need to analyze. Then you will pick up some important words. Based on the words, you will tell that person is satisfied with your service or not satisfied with your service. So here we are look at all the things based on the text related things. If it is a numeric, it's very easy. But here we are look at everything is text related things. So we need to do some mathematical calculations to find out whether this document or this review contain this kind of words or this kind of words. Based on this, we will find out this is acceptable by the customer or not accepted by the customer. Do you have any doubts up to now? Do you have any
No,
doubts?
sir.
Okay.
No, sir.
If you think about the text data, they have some unique values. Let's think about your exam papers, your answer scripts. Let's say, just think about your batch. There are 65 students. Let's imagine 65 students are there. Is it 65 students get same marks? Is it possible? No. Why is it not? It is not possible. The way you express your ideas is different. Let's think about, you all have the answer, but the way you express your answer is different. Someone is express the answer in clear way, all the important aspects he mentioned. Someone is just write only 1 or 2 important aspects, he missed lot. So if someone is provide full answer, we will give full marks. Someone is answer just 2 or 3 things, very few things, we definitely reduce the marks. So each and every answer, each and every text have some unique values depending on the way they express their ideas. That's here what we are saying. If you think about the text documents, they have unique values. Let's think about your search in the Google. Google provide you 10 pages, 1, 2, 3, likewise 10 pages. You are searching something called AWS Lambda. This is one of the cloud computing features they introduced by Amazon Web Services, AWS Lambda. Then they will give you some important or related things, related links in the first page. Also, they will provide you in the fourth page. Which one is most appropriate one? Someone tell me. Whenever you getting answer, which one you choose for selecting the answers? Someone tell me.
First page.
Whether first page. Why you are choosing first page? The first page articles are highly appropriate or highly related to your search terms, search keywords. How they will find out it's highly related? They will do some text mining algorithms and they will give some marks for them. So based on the marks, the first page articles are get high marks. Marks in the sense they have some high value compared with others. So what we are saying here, different documents have different values. We can't say, just think about your answer, say it. Also, we are providing the answer, but the way you are express is different. Different people express in different ways. Based on their expressions, their value of the document is changed. That's why we different students have different marks. Even whenever we will give you an open book exams, it's not guaranteed all the students get same marks, because all are accessing the same internet, same documents, but the way they are expressed, the answers is different. Someone is miss some parts, someone is gives only small answers. So the value of the text data is different from person to person, or from location to location. The value of the text data is different. Do you have any doubts? Let's think about, you are purchasing something from Daras. What you are look at whenever you are purchasing something from Daras? What did what you look whenever you are purchasing something from Daras? Let's say someone is need to purchase one mobile phone. At the time, you search in the Daras and they will recommend you some devices. Among the devices, what did you search? Someone tell me. You are searching the features, whether you are checking the prices, whether they have provide warranties, and everything you are checking. After that, you are looking the customer reviews. Anyone have experience with it? Did you look at the customer review or directly purchase? What did you recommend? Someone tell me. Whenever you are purchasing something, you are look at the customer reviews, customer comments, or did you are directly purchase something without checking the comments of the customers? What did you do?
We are review customer comments.
Yeah, we are review the customer comments. So whenever you are review the customer comments, you can find out whether this seller is good or not, whether the product is good or not, whether the product is what they are explained, or it's have some defects. Everything you can look at. Am I correct? So at the time, the customer reviews are just 2 to 3 lines. Even someone is provide only one word comments or 1 to 2 word comments. From their comments, you will utilize whether it's acceptable or not. So what we are saying here, the value of your text is very, very important. Whenever whenever you are post something in the social medias as a comments of someone's post, you need to think about it have a lot of values. Even it can create some wars among the people based on the comments. That much value for your texts you're posting on public places. Whenever we are in the first lecture, we have prepared, we have some data. From the data, we have collect some information. From the information, we are getting knowledge. So that information, one way that information is text data. Even we have some text data as a information. Not only the numeric data consider as a information, any text data also consider as a information. Okay. The important thing is their value is different. Okay, now we will look at what is text mining. Text mining means it's, we already discussed data mining. Data mining means we will find the similar patterns from the data. Similarly, if it is a text mining, we will find the interesting patterns or interesting things from the large amount of text data sets. Let's say you are collecting some comments Or let's say after conducting this lecture, I am getting a feedback from you all. Whenever I have 1,000 feedbacks, I will go through the 1,000 feedbacks and I will go some based on the feedbacks, I will go for some decisions, whether the pupil enjoy the lectures or whether the pupil didn't understand anything. Likewise, we will find out. Similarly, we are doing here is based on their texts, text documents or text files, we are extracting some useful informations. If it is only 3 to 5 documents or 3 to 5 papers, we can easily read and understand. Let's think about we have 10,000 or 50,000 articles. It's very difficult to do manually. That's the way. That's why we are doing text mining. The text mining in the sense we need to find some interesting patterns, finding interesting regularities. If it is an interesting mean, they have some significant value. They are hidden, not directly found. It is previously unknown. No one is already don't know about the information, but we are extracting from the text documents. Important, it's potentially useful. Those things you need to consider. Let's say we have 1,000 web articles. From the web article, you are finding something similar patterns. That pattern does not have significant values. So it's that text mining is useless. Whenever you find something, it's not already exist. Even whenever you are doing a research, you can't do the existing things. You need to find some novelities in your research. Novelty in the sense previously unknown. No one is know about the things what you are produced by the text mining. That is the important thing is you need to consider whenever you do some text mining task. Even whenever you do some text mining for some government websites, or whenever you can find, let's say you have a shop, online shop, by analyzing the customer comment, you can decide whether the shop provide good services or bad services for their customers. Even whenever you analyze the comments of the individual person, you can decide whether the person's behavior, which kind of person he is. Likewise, you can do and find something from their comments or text data sets. Even whenever we are correcting your answer sheet, we will find or we will mind something about you based on the way you answer, whether you are answering with proper knowledge or you are copying from someone else. How we will find you? Whenever we go through you the entire paper, we will analyze you, which kind of person you are. Even without looking your faces or without physical interaction, we will find out. How we will find out? By only look at your answer scripts. Just contain the answer scripts, only the texts. By look at the texts, we will analyze your behavior. Everything we can find out about you. So in the text mining, we are finding some interesting patterns. Now we are look at text retrievals and text analysis. Do you have any doubts up to now? Hello, do you have any doubts?
No, sir.
Okay, now we will move to the text retrieval and text analysis. Someone tell me what is text retrieval? Someone tell me an example with text retrieval and text analysis. What do you think? Don't need to fear to answer. It is not an exam. Just we are discussing the content. I need to tell you what is text retrieval and what is text analysis. What did you understand by look at the title? Okay, I will explain with a simple example. Let's imagine you are doing a research for your final year. At that time, the initial step you need to collect some research papers. First step is you need to find the related research papers. At the time, you can use some e-libraries, IEEE Explorer or Springer, Emerald Insight, or there are a lot of e-libraries are there. Go to the libraries and you will enter the keywords for your topic and you will collect some research, or you can download some research related to your keywords. That is called text retrieval. You are retrieving the documents from the internet from different electronic libraries. After you are collecting the papers, you can go through the abstracts, or you can go through their title, and you can go through their introduction. Based on these, you will cluster the papers, whether I will accept this paper or I will omit the paper, or you will categorize. This is related to image processing, this is related to feature extraction. Likewise, you will cluster the papers. That is called text analysis. Just retrieval in the sense you are getting some articles or documents which related to that keywords. That is called retrieval. But if you think about the analysis, you will go through the document inside and you are checking that abstract, whether it's related to our research or which technologies they are used. And then you can go through the methodology and you will entirely analyze their document inside and you will cluster the papers, or you will categorize the papers. That is called text analysis. Retrieval in the sense just we are searching something and get something. But if you think about text analysis, you go inside the document and you will categorize, you will analyze the documents. Do you understand what I'm saying?
Yes, sir.
Let's think about in Twitter, there are some APIs are there. You can use that APIs and you will collect the 1,000 or 2,000 tweets. That's what you need to do. You need to provide some keywords and they will check that keyword is there and they will download, or they will provide us a research or report for all the tweets which contains that particular keyword. But whenever you need to analyze the text means you will go through the tweets one by one and you will remove that some words. There are stopping words you need to remove. There are some different stemmings you need to do. We will discuss a little bit later those things. After you do all the things, you need to analyze. That is totally different. So text retrieval is very, very easy task. But if you think about the text analysis, you need to do a lot of things. You can't do directly for any text documents without doing some pre-processing task for that documents. Okay, the important thing is you need to differentiate text retrieval and text analysis with your own words. What do you think? That is what we are expecting throughout this slide. Okay, now we will look at how we will represent taxes. Someone tell me how you will represent taxes. Sometimes you will represent taxes as a character level representation. Did you have some experience whenever some secretary taking minutes, they will put some only one character or only one character to indicate something? Did you have some experience likewise? The reporters, whenever taking the news information, or taking the information from an interview, they will use some specific characters. Based on the characters, they will represent. Just think about the likes buttons in Facebook. They have like buttons, heart buttons, laugh buttons. So what they are doing whenever someone is posting something, you will click the like button. At the time, you are putting some information related to that article. If you are put some hearts, you are indicate something different. If you are putting laugh, it's totally different things. How they will find out by using it is a single character. It's a hand likewise. If it is a like, it's a hand, no? So it's a single character they are using to represent the informations. Whenever whenever you are post something, you can find out, or whenever you post related to some questions, based on the answers, you can find out at the time what you are doing. You are representing by a single character. Even we can use one character or two character or three character, depending on us. It's depending on our decisions. But we can represent the text by using characters also. Another way of representing the text is we can use bird level representations. This is the most common representation of texts we use. Word level in the sense we have whenever someone posts some achievements, we are comment as a congratulations, do go ahead, or happy for hear about the news. Likewise, we will put no. That is what we are expressing the post by using some words. Whenever someone posts some sad news, we are posting rest in peace. Likewise, but at the time we are using word level representation to express our behavior or express our emotions. Am I correct? Rather than the character level representation, most of the time we are using word level representations. The important thing is whenever you are finding a document, you can't go through the every words in that document. So we need to omit some words. Stopping words are there. There are some article letters are there. There are conjunctions, prepositions, sorry. There are some conjunctions are there. There are some prepositions are there. You need to remove each and everything from the document. You only consider some specific things. Those things are a little bit later we will discuss. But whenever you are represent the text by using words, it's very difficult thing to extract the important words from that document. Let's think about one page of a book. It contains thousands of words. Among the words, you need to think about only the few filtered words. Others are meaningless words. So you need to remove the meaningless information from the words, and you need to consider only that specific filtered words. That is the way you can do the text mining. If you think about the properties of words, give me a minute. Hello, can you hear me?
Yes, sir.
Okay, thank you. If you think about the words have different properties. One property is homonymy. Homonymy in the sense they have same form but different meanings. How we say the same form but different meaning. If you think about word bank, where we can use bank. So we can use the word, bank for indicate the financial organization. Am I correct? Similarly, the river bank also is there. So this type of words we can say homonymy. Sorry, homonymy in the sense they are in the same form, but they have different meaning. Another way, follows me in the sense they have same form, but they have relatedly same meaning. The similar word bank, we can indicate blood bank. Blood bank means it's also a institution which collect the bloods, whether for emergency purposes, they are collecting the different group bloods, and the hospitals are communicate with them to get that blood groups. Also, financial institutions, both are doing the same functionality. They are using money as a object. They are using blood as an object. But here, both are similar meaning, related meanings. That is called polysemy. Synonymy in the sense they have different forms. There are different words, but they have same meaning. Just think about singer. The person who sing a song, we can call as a singer. Here, vocalist. Vocalist also the person who sing a song. Both are give the same person. The person who sing a song is called, but the words are different. That is called synonymy. Hyphonymy in the sense one word denotes a subset of another. Let's think about the breakfast and meals. Breakfast is a subset of meals. Breakfast also a meals, right? Even we can say lunch and meals. Lunch is also a meals. So lunch is a subset of meal. So that is called, we can say as a hyphonymy. One word denotes subset of another. These are some properties of words: synonymy, hyphonymy, polysemy, and homonymy. Homonymy in the sense they have different meanings. Same word, different meaning. Same word, related meanings, we can say polysemy. Synonymy, different words, same meaning. Hyphonymy means they are one word denotes a subset of another. Do you have any doubts up to now? If you need more examples, you can Google it. Just type the homonymy and you can go through some articles, or you can go through some examples related to homonymy, polysemy, synonymy, and hyphonymy. Okay. One of the important properties of word stemming. Stemming in the sense the different forms of the same word are usually problematic. Let's say sometimes we say learn. Sometimes we are learn. We are saying learn. Sometimes we are saying learning. Sometimes we are saying learns. The different words give the same meaning. The same things, they are learn something. So whenever you are doing text mining tasks, rather than we are considering this as a different, this as a different, and this as a different thing, we look at all the things as the same, and you can use a single word for all these three. We are put learn. So it's very easy. Whenever we are putting these three different words, it's very difficult to find out the similarities from the documents. To avoid these, we are using the stemming. In the stemming, we use one normalized form for these three words. That is called learn. So what they are saying here is different forms. This is one different form. This is past. This is continuous. They have different forms of the, but they are providing the same meaning. Learning is the same meaning. So those kind of words are normally problematic. To avoid the problem, using, we apply the normalized form for all these three words. Did you understand what is stemming? Stemming in the sense we are transform the word into its normal form. Someone tell me an example similar to this. Someone tell me. Someone tell me an example. You can do stemming. Place, plate, playing. So for these three words, we use play. This is the normal form of these. So rather than this is one form, this is another form, this is another form. Rather than we are using these different forms, we use the normalized form called play. So whenever, let's say you have a document, in that document, whenever they have place, we replace this place with play. Whenever we find plate, we replace with play. So it's very easy. But if you think this and this, definitely the computer find out these are two different things. But whenever we replace with normalized form of stemming words, then its computer find out it is the same thing. That is very helpful to do similarity findings. That's why we are changing the stemming words into normalized form. Do you have any doubts? Do you have any doubts regarding this? Hello? Do you have any doubts regarding this? I don't know whether you are in the session or not. Just if you have any doubt, just raise your hands and ask me the questions. I can't understand this thing, these things. So whenever you be silent, I can take as a you can understand. Definitely, I will ask a question, what is stemming? Sometimes I will give an example. You need to tell the stem, normalized form of the stem. So without the clear understanding, you can't answer for that questions in your final exams. That's why I am asking you again and again. Just if you have any doubts, tell me. Okay, let's move to the next things. The another important properties of words are stopping words. What are the stopping words? Someone tell me. Stopping word in the sense there are meaningless words just for the completeness of the sentence or just combine the sentences. We are using the stepping words, but they don't have any information. But by look at the stopping words. So whenever you are doing the text mining task, you must need to remove all the stopping words. It's very helpful. If you think about the stopping words, they are different to different language. It's totally different from English to Sinhala, English to Tamil. So whenever you analyze some articles, you are the one, you need to decide which language we are analyzing the article. Depending on the articles, you need to remove the stopping words. If you think about the English, A is a stopping word. A, N, S, above, about. These are some examples. These are used for the completeness of the sentence. They don't have any meaning. So we need to remove these stopping words first from our data sets or text documents or text data. Do you have any doubts up to now? Do you have any doubts? Hello? Do you have any doubts up to now?
Sir, can you please explain again stop words?
Stopping
Stopping.
words, no? Is it related to stopping words, no?
Yes, sir.
Yeah, stopping word is a word properties. Why we are considering stopping words? Let's think about you have a paragraph. Let's think about the paragraph in an article in a newspaper. That article contains lot of words. So here what we are doing is we are doing text mining. Text mining in the sense from the text paragraph, we are find some frequent words, and based on the words, we will cluster the article into different types or different category. So whenever you are categorize the article without removing the stopping words, what will happen? You can't find exact meaning. If you think about that article contains a lot of words. The purpose of that word is to combine two sentences. Sometimes they will indicate something. Sometimes they will use for to get some meaning for the entire sentence, but they don't have any meaning as themselves. Let's think about here. Just think about this sentence. My sentence, just think about this sentence. Even this sentence also have some stopping words. This is meaning. This word is meaning. This tells something, but this I is not meaning. Why I am using this? This is a plural, so I am using are. The words are have some meaning, but that is not meaning. Why I am using that? To combine this sentence with this. From also not meaning. Not is meaningless. So whenever you are look at a sentence, we will find out only some. Just give me a minute, I will show you an example. Just think about this is an article, okay? You need to find out which type of article this is, or you need to do some text mining related to this article. So first important thing is you need to do some pre-processing. One of the pre-processing is stemming. Stemming in the sense you need to analyze different words. Sometimes they are using analyzed. Just think about here. Sometimes they are using analyzed. Whenever you go through the entire document, you can find out the synonym word called analyze, analysis. All are same meaning. So you need to remove these words and you can replace this word with analyze. That is called the normalized form. You use normalized form everywhere which contain different forms of analyze or analyzing or analysis or analyzed. That is one way of pre-processing. Another way of pre-processing, you need to remove the stopping words. Why we need to remove the stopping words? Stopping words they don't have any meaning. Just for the different purposes we are using the stopping words. Just even we are combine the sentence or completeness of the sentence, we are using the stopping words. Let's think about here. This rainfall is daily, is a meaningful. Rainfall is meaningful. Total is meaningful, but I is not meaningful. For is not meaningful. The is not meaningful. Main is meaningful. Agroclimates, zones. Off is not meaningful. Sri Lanka is a meaningful. This is indicate a country. For the is not meaningful. The period is meaningful. This is also meaningful. We use different techniques to convert these forms. Okay, we will look at little bit later. The is not meaningful. Emphasize. Sometimes they are use emphasizing. Sometimes they use emphasize emphasizes. So you need to remove these different forms of emphasize. Just you are putting the normalized form of the word emphasize. Is on is not meaningful. Likewise, you will remove these words. Only you are picking that words which related to that document. This is meaningful. This is meaningful. Then is not meaningful. On is not meaningful. Longer period. Totals. In is not meaningful. Particular meaningful. The not number of daily false exceeding. Even also we will count how many times these words are occurred. That is the way we can do the removal of stopping words. You need to go one by one. You will remove that stopping words and you will only pick up the some words which are related to that articles. Okay, I will share the screen. Okay, I will just give you some simple examples. You can see my slide screen, right? Am I correct?
Yes.
Okay,
Yes, sir.
thank you. Okay, thank you. So I will just give you some example. Article letters A and these are called article letters. So you need to remove them. Likewise, there are a lot of different types of stopping words. You need to find out. M is those are stopping words. So you need to remove all the things. The important thing is they don't have any meaning or meaningful information they contain. They can only contain for conjunction purposes or completeness of the sentences. So you need to remove those things. Do you have any doubts? Hello, do you have any
No, sir.
doubts? Okay,
No, sir.
okay, thank you. Okay, I will continue. I don't know whether it's complete by today. I will try my best. Okay, now we will move to vector space model. This is one of the model we use to text mining purposes, where we can use this vector space model in documents. Let's think about you have 10 books. Each book have 25 pages. So you need to find out how many different words are there. What is the number of times these words are located? Likewise, you need to find out or you need to convert your text document into a different data form. That is very, very important for text mining purposes. So here, what we are doing here, let's think about, I have 50 papers, okay? Each paper have printed double side. I will provide 50 papers for 50 students. You need to find out different in that paper, different words are there. No, you need to find out how many times the word apple is there. So how you can find out? You can go through the line by line and you will check whether this word is there or not. Likewise, you will count. Similar things we are doing in vector space model. Vector space model in the sense we have a document or we have a paragraph. In that paragraph, we need to find out how many words are there, how many times each word indicate or how many times each word represented in the document. That is the we call vector space model. The most common way to deal with documents is first to transform them into sparse numbers. This is very important. Sparse numbers in the sense, let's think about we have a paragraph called I need to go hospital. So here, and I am hungry. This is the paragraph I have. Okay. Now I need to find I how many times I is there? Two times. How many times need is there? One. Two is one. Go is how many times? Likewise, you need to complete. This is called vector space model. We call this is as a vector space model. Also, we can call this as a bank of words. Even sometimes we ask you just explain about vector space model or back of words model. So both are saying the same thing, what we are discussed here. What here we are doing is we are classifying or clustering the words. Which words are there? How many words? Different words are there? How many times each verse occurred? Likewise, we will find some information. I will show you an example, then you can easily understand. Let's think about this is a paragraph. Let's think about this is the paragraph it have in the document or it have in the paper I will give you. As a student, you need to find out how many times each word is there. Just for an example, I already told you, you need to remove the stopping words. So here they are removing this one, this one. So first word is beginning. So they are writing this word and how many times? One time. Then they are putting God, one time. Just one time. This is one time. Then created. So we will put as a create. Sometimes creates, likewise different forms are there. For advanced purpose, in advance, I will put as a create, as a normalized stemming form. So create is one time. Again, we will remove this stopping word, the heaven is there, one time. And the is removed. Earth is come first time, okay. And this removed, the is removed. Earth is come second time. Verse is removed, without, form, and then we can remove void one time. And darkness, verse, likewise God is again coming. Similarly, you need to find out how many occurrences of each word in that document. That is we are calling vector space representation or bag of words. So you need to avoid or you need to remove the stopping words and you need to count how many times other words are occurred in that document. Okay, that is we are called bag of words. This is only for one document. Now I will give you 50 documents for 50 students. So I need this type of 50 tables. Not all the words are here and other person's tables are not same. They are different because the content of each document is different. Then the table is also different. Did you understand? So this is we call bag of words. So in final exam, I will give you a paragraph and that paragraph contains some stop words, including stopping words, stemming words. So you need to remove or you need to avoid the stopping words and you need to mention these are some stemming words. Then you need to give some normalized stemming form. Then likewise you will do and you will create the table. How many times each different words are located in the document. After that, we need to do some calculations. So now we need to find the weights of the words. We need to calculate the weights of the words. To calculate the weights of the words, first step you need to find out the back of words table. It's very important to calculate the weights of the words. In weights of the word, each different word consider as a separate variable. This is one separate variable. This is one separate thing. This is one separate thing. Create is separate. Heaven is separate. Void is separate. Darkness is separate. So we need to find out the weights for each words. Let's say we need to find out the weights of earth. It means how many times this word is located in the documents. Similarly, sometimes we need to find out the weight of God. So it's a different variable. It means each word have different weights in the document. So one of the equation or one of the method we will calculate the weight is called TF-IDF, term frequency inverse document frequency technique. So in your final exam, I will ask you, you need to find out the weights of the words by using term frequency, term frequency inverse document frequency technique or methodology. You need to apply this methodology to calculate the weights of each words in the given particular documents. That is the way I will ask the question in your final exams. Now you need to find out how you can find out this term frequency inverse document frequency values. This is the equation to calculate the TF-IDF. This is not minus symbol. This is not minus symbol. This is a one word. To indicate both together, I will put this minus. Okay. So the important thing is you need to familiar with how you can calculate the TF-IDF. So to calculate the TF-IDF, you need to do two things. First of all, you need to calculate the term frequency. Second thing, you need to calculate the IDF. Then you can multiply by TF and IDF. That is called TF-IDF. If it is a TFW means this is we need to calculate. This is the name of this. This is a word. Like let's say you need to find out the TF-IDF of Earth. Based on this previous document, you need to find out the TF-IDF of Earth. For that, you need to calculate T of Earth. T of Earth means you need to find out the term frequency. Term frequency means number of words occurrences in the document. It means number of word Earth occurrences in the document. It means, let's say you have a document. In that document, you need to count how many times the word Earth indicated or located in that document. That is called term frequency. If you think about this IDF, it says inverse document frequency. It means you need to find out how many documents the word Earth is there. D of Earth means you are calculating how many documents that contains the word Earth. N means the total number of documents. Let's think about in our previous example, I will give you 50 different documents. No, 50 students, I provide 50 different documents. So here, total number of documents N is equal to 50. Among them, I will give each document for each student. So that student creates his table. What words are there? So student one creates a table. In that table, it contains school. School occurs 15 times. Also, earth occurs 5 times. Likewise, he will write other words too. Mango have 8 times. Likewise, he will create. Similarly, student 2 creates his table. Here also it contains sports 8 times, earth 2 times. Student 3, his table not contain earth is here. Sorry, here there is no earth. Okay, only it contains balloons 55 times. Likewise, he will create. If it is a TF, term frequency means we need to find out for each document. For this document, how many times it will create it. How many times the word earth is there? Here 5 times, here 10 times, 15 times, like, sorry, here, this is not earth. So you need to calculate how many times, sorry, this one. For this document, for, let's say we are calculating the TF-IDF for document 1. If whenever you are calculating TF-IDF for document 1, you need to find out the TF in the sense term frequency. So the term is what? Earth. So here you can find out the earth is located in 5 times. So 5 multiplied by log to the power of total number of documents 50 divided by document frequency. Document frequency means among all the documents, how many documents have the word earth? This one contain. This one contain. Let's say other documents don't have. So how many documents have the word earth? Only 2 documents. So we are putting here is 2. So you need to find out the log value of 25 and multiple by 5. You can find out the TF IDF values. Did you understand? I will explain you with an example, then you can clearly understand. The important thing is you need to find out the weights of the words. To calculate the weights of the words, you need to find out the TF IDF values. That is one way of calculating the weights. TF IDF means you need to calculate the term frequency. Term frequency means, let's say you need to calculate the term frequency of the word employee. So you need to calculate how many times that word employee included in the document. Similarly, you need to find out the inverse document frequency, IDF. For calculating the IDF, you need to calculate total number of documents divided by how many documents which contains the name employee. So among total number of documents, you need to find out how many documents they are indicating that employee. Let's say among 10 documents. So to calculate the IDF, you need to find out log here total number of documents 10 among 5 documents. Let's say 5 documents are there, that 5 documents in contains the employee. So log 2, you need to find out the value of log 2, that is considered as an IDF. This is the way you can calculate the word weighting. This is an example. Here you need to find out the weight by using TF IDF values for the word of economy. The word indicate by, or the word they are mentioned as economy, you need to find out the TF IDF value of economy. To calculate the TF IDF value of economy here, first of all, you need to find out what is the term frequency of economy. This is the equation. You need to calculate the term frequency of economy. Similarly, you can multiply by the term frequency of economy by inverse document frequency. So you need to find out the IDF of economy. For calculate the IDF of economy, you can use this equation. So by using these 2 equations, you can find out the TF IDF value of economy. To calculate the term frequency of economy, first of all, you need to find out number of times the term economy appeared in the document divided by length of the document. Let's say in that document there are 50 words are there. Among the 50 words, let's say student 1 contains a document, that document contains 50 words. Among the 50 words, how many words they are mentioning the term economy? Let's say only 3, or let's say only 15 times they are mentioning the term economy. So here we are calculating the TF term frequency of economy is equal to 15 divided by 50. That is called 3 divided by 10. It is equal to is equal to 0.3. This is the term frequency value. Similarly, you need to calculate the inverse document frequency of economy. For that, you need to use this equation. This equation says log in the top, you need to do number of documents. Let's say we have 10 documents. Among the 10 documents, all 10 documents says, or all 10 documents contain the word economy. So 10 divided by 10. So log 1. We already know log value of 1 is equal to 0. Did you learn these things in your mathematics? If anything, you when for any log, you get log value for 1. For whenever you are getting the log value for 1, it is equal to 0. Let's say I will in mathematics we have some logs. Whenever you are getting log 10 to the power 10, it is equal to 1. Whenever we are getting log 10 to the power 1 is equal to 0. Similarly, whenever you are getting log 20 to the power of 1 is equal to 0. The theory is whenever you are getting the log for 1 in any base, it is 0. If you are getting the log for any number that is also the base, the number and the base are same, the value is equal to 1 whenever you are getting the log. This is some theories or some rules in mathematics. So 10 divided by 10 is equal to 1. So log 1 is equal to 0. Then you need to multiply by 0.3 multiple by 0. The weight is equal to 0. Sorry, weight means that TF, the TF IDF value is equal to 0. That is the way you can calculate. Okay, now we will look at the step by step, how you can find out or how you can calculate the weight. First of all, whenever someone is providing a paragraph or document, you need to clean the document. Did you understand? Similarly, whenever we are doing data mining, we do pre-processing. Here, we need to clean the data, clean the paragraph. That is the first requirement. After the cleaning the paragraph, we need to do tokenize the word with frequencies. Tokenizing the word with frequency means that bag of words table. This is called tokenizing with frequency. How many times each word occurs in the document. That is called tokenization. Third thing is you need to find out the term frequency. We already know the equation for find out the term frequency. You need to calculate how many times or how many repetitions that word occurred in the document, and you can divide it by total number of words in the document. So after whenever the initial state, that paragraph contain only around 100 words. After you are doing the data cleaning, we definitely say there is no 100 words in the documents. Because of that, we will remove the stopping words, or we will remove some stemming. Because of that, definitely the number of words in the document is reduced after the cleaning the stuff. So you need to find out this one. As a third step, you need to find out the how many times the word economy repeated in the document divided by the total number of words in the document. After that, you need to find out the IDF value. How you can find out the IDF value? Log total number of documents that contains the word economy divided by total number of documents we are considering. If you calculate the IDF, first of all, you put log. Inside the log, in the top, you need to put total number of documents without considering anything. In the bottom part, you are putting the total number of documents that contains the word economy. So let's say that we have 50 documents overall. Among the 50 documents, only 5 documents contain the word economy. So you need to calculate the value. For that, you can divide log 10. So you need to calculate the log 10 value. That is called IDF. After that, you can multiple both term frequency and inverse document frequency. That says or gives the result of weight of the document. Do you have any doubts up to now? Hello, do you have any doubts?
No, sir.
Okay, thank you. Okay, I will explain with an example for you. Okay, let's think about, I have 2 documents, okay? I have 2 books or 2 papers. That papers contain these 2 paragraphs. One paragraph says this content. Another paragraph says this content. So I need to calculate the TF IDF values. That is my question. I already told you, first step is you need to clean the data or pre-process the data. Am I correct? So let's these some examples we can do the pre-processing steps. Let's look at one by one. First one, they are saying that you need to convert the paragraph into the lowercase. Sometimes whenever you are looking, the first letter of first character of each word becomes uppercase. So you need to, this is also uppercase. So what you need to do in the first step, you need to convert all the entire paragraph into the lowercase. Did you understand what I'm saying? You need to convert the paragraph into lowercase. Why we are doing that like that? Sometimes whenever you are calculating by computer, it will consider this apple and these apples are different things. To avoid these conflict, we use always. Let's say someone is writing likewise. Last letter is capital. So computer decides this one is different word, this one is different word, this one is different word. To avoid these things, we are converting the entire paragraph into the lowercase. So everything in lowercase. So there is no problem here. So that is one pre-processing. Sometimes a document contains some HTML tags. What are the HTML tags? Sometimes this paragraph, likewise, is there HTML tags, bold is there. Likewise, there are a lot of HTML tags are there. So you need to remove the HTML tags from the document. This is second one. Sometimes your document contains some URLs. So you need to remove the URLs. This is one way of pre-processing. Remove the numbers. Sometimes your paragraph indicate 2 times. So sometimes you need to remove these. Sometimes you need to convert these 2 into words. Or 5 mangoes. So sometimes you can remove, sometimes you write likewise. This is 2 ways. Sometimes you are removing the numbers, sometimes you are converting the numbers. Then you will apply spell corrections. Sometimes your paragraph contains some spell mistakes, so you need to correct those, all the mistakes. Sometimes your paragraph contains some accentic characters. Likewise, if you think about these double E's or this E, this is a special character, accentic character. So you need to remove or you need to convert into ASCII characters. What are the ASCII characters? normal ease. So you can replace with these ease by ASCII E values. Sometimes you need to convert the chat conversion. Sometimes we put OMG for oh my god. So you need to remove these chatting terms. Or you need to convert into the long form. Expanding the constructions. Sometimes they are putting short forms. So you need to remove these. So you are putting do not, don't, likewise. So you need to remove and you put likewise, this one. Then we already discussed stemming. You need to do the stemming parts. Then also you need to remove the emoji. Some paragraphs contain some emoji. So you need to remove them. Also, you need to remove some special characters. Or sometimes we are putting this way to indicate the emotions. So you need to remove these also. Sometimes we need to convert the emojis into words. If whether it's sad, rather than we are remove these and put sad, that word. Sometimes we are converting the emoticons words, emoticons to words. Emoticons mean this one. This is also convert into words. Emojis also convert into words. Emoticons also convert into words. Sometimes we need to remove the punctuations or special characters. Remove the stopping words. Remove the frequent words, rare words, single characters, extra white spaces. Everything we are considered as a data cleaning. Do you have any doubts? This is the way we can do the pre-processing of words. So you need to check all the things whenever you are look at the calculating the TF IDF values. Do you have any doubts? Hello. Do you have any doubts?
No, sir.
Okay. So now we are look at data cleaning. So I have two documents. I already told you these are the two documents. Whenever you go through the documents, you need to do the data cleaning. So this is I need to remove. Am I correct? This is a stopping word. This read is stopping words. Again, in is stopping word. There is no others. So I will remove the stopping words. After removing the stopping word, this is my paragraph. Now this is my paragraph. Then what to do? Next step, I need to find out the words and their frequent count. Am I correct? That is we are calling as a tokenization. So here, what I want to do here, I will pick the first word, read. So how many times the word is located in document one time, document two, one time. Similarly, I need to find out each and every words one by one, and I need to look at how many times each word are located or indicated in the documents. This says likewise. So you need to prepare this document again. The third step, you need to find out the term frequency. So I am calculating the term frequency of each words in document one and document two. Let's think about how I will calculate the term frequency. I need to count how many times the word repeated in the document divided by total number of words in the document. So here we need to calculate 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Both documents have same number of words, 6. So now I already know that count is 1. So the word, so here what I am doing here is term frequency of the word read. Here I am doing term frequency of the word SVM. Here I am doing term frequency of algorithm. So term frequency of read means number of repetitions of the word read in the documents. How many times word read? 1. So 1 divided by total number of words, 6. So 0.17. Likewise, I will calculate each and everything for all. Similarly, I need to do the document 2 also, the same thing. In my fourth step, I need to calculate the IDF values. To calculate the IDF value, I already know the equation is log number of documents divided by number of document contains the word. So here I am calculating the IDF of read. Here also IDF of support vector machine. So I already know how number of documents, total number of documents we have how many? Already know we have 2 documents. Among the 2 documents, how many documents indicate the word read? Someone tell me how many words? How many documents contains the word read? This word contain in document 1 and document 2. So I am putting here 2 divided by 2. So log 1 is equal to 0. If you think about the word SVM, we can calculate the IDF log total number of document is 2 divided by how many documents contain the word SVM. Someone tell me how many documents contain the word SVM. Someone tell me. Only one document, because the document 2 doesn't have this word. So only one total number of documents which contains the word SVM is 1. So now I am divided by 1, not 2. That equation says number of documents contains the word SVM. If you are checking here algorithm, number of documents contains the word algorithm. So log 2 you can calculate, find out the value by using scientific calculator, it's 0.3. Similarly, you can continue for all. Just someone tell me how many times the word clustering, total 2 documents divided by how many documents contain the word clustering? Only 1. So log 2, this is called log 2. It is also 0.3. This is the way you can calculate for all the IDF value. Then you need to multiply by term frequency and IDF values. So it's a normal thing. This is, we already know 0.17. Here IDF value is equal to 0. So total 0. 0.17 into 0.3, 0.05. Likewise, you can calculate. This is the weight of all the birds. Okay. This is how we can calculate the weights of words. What do you think similarities? Someone tell me. What do you think about similarities? In different ways, we can find out similarities. Someone tell me how you can find out similarities between 2 objects. Let's think about, you have 2 balls. Then you will check, you want to check the similarities between them. How you will check? Which attributes you will check for similarities? Someone tell me which attributes you will check for similarities between 2 objects. Even consider there are 2 chairs there. Between these 2 chairs, you need to find out the similarities. How you will find out the similarities? Which character you will consider for similarity calculations? Even tell me one character you will check for find out the similarities. You can check the color attributes, size attributes. You will, if it is a chair, you will check the height of the height, or you will check the design. There are a lot of things you need to consider whenever you are considering the similarities. Similarly, here we are checking the similarities between the texts. Okay. Similarity means we are checking how much 2 objects are similar to each others. A similarity measure is the measures how much alike 2 data objects. If you consider 2 paragraphs, you will check how much have similarities between these 2 paragraphs. Or let's think about, this is a tweet 1, this is tweet 2. So you will check the similarities between 2 tweets, how they are similar, how they are similarity between each others. Those things we are considered. Whenever you are the similarities between the texts, you need to consider different dimensions. Let's think about, we are looking the similarities between two students, student 1 and student 2. At the time, we not only consider only one attribute, we are look at different attributes, whether we will consider the hair color, his hair color, we are consider his weight, his height. What else? We are considering lot of attributes. So whenever we are calculating the similarities between two objects, we need to plot in a graph. Let's think about here. Whenever we are calculating the similarities between two students, this is weight. For your understanding, I will put only two attributes, weight and height. Let's say student 1 height is 1.5 meter and weight is 45 kilograms. Student 2's weight is student 1. Student 2's weight is 85 kg, 85 kilograms, and is 1.75 meter. So this is student 2's details. So here we are considering two different attributes. Then we need to find out this distance. This is called the similarities. What will happen? The distance is reduced. Let's say now this distance is 3 meter. What will happen? This distance reduce. They are more similar or less similar. Just think about, this distance is now this one. Some student have this student 3 this time. So this distance is very low. What will consider about the similarities? Student 1 and 2, they are less similarity. They are less similar objects. But if you think about the student 1 and 3, they have very low distance between them. So they have similarity, more similarity compared with the student 1 and 2. That is the way we will find out. How we will find out the similarities? By look at the distance between the objects. That is they are mentioning here. Similarities measures in data mining context. They are look at the distance with dimensions. Dimensions in the sense we are using only two dimensions here, height and weight. Sometimes we are considering n number of dimensions. Even we can look at the color, iris color, or body color. Likewise, we will consider different dimensions to find out the similarities. For your understanding, I will only told with two dimensions, height and weight. So whenever we are looking at different objectives, we are considering different number of parameters or attributes or dimensions. What will happen if the distance is small? They are highly similar objects. There are lot of similarities between them. If the distance is small means they are close to each other, so they have lot of similarities. What will happen if the distance is very large? If the distance is very large, they don't have more similarities. They are less similarity objects. They are totally different, it means. Do you have any doubts? Hello, do you have any doubts? Did you
No,
understand
sir.
what I'm saying?
Yes, sir.
Okay. The one of the important thing is similarity is subjective. It's depending on the domain and applications. Let's think about, we are finding the similarities based on their color. It is a one domain. So sometimes we are look at the similarities based on their size. Let's think about the mango. whenever we are pick up the mango, we are look at by colors. If the color is golden color, it's very fruitful. If the color is green, it is not fruitful. So one situation, we are only look at the color. Some situation, whenever we are picking mangoes, sometimes we are picking the size, whether is the size is large or small. Depending on the size of the mango, the prices are different. So in this point of view, we are calculating the similarities by size. Sometimes we are calculating the similarities by color. So the similarity calculation is subjective. It will change by different characters, what we are considering. Even the taste, they will consider the taste. Different varieties of mango have different taste. So these are some examples of subjective characters for find out the similarities between the objects. Even whether if we are considering the similarities between two chairs, we can't apply the taste. Only we apply the color and the size. Especially size means the height of the chair or the comfortability, which material they use. Depending on these, the similarities are different to objects. So whenever we are doing this similarity calculation, we need to find out for what we are doing. We are find out the similarities. Depending on these, it will change. Understand? One of the important thing here is whenever we are look at the similarities, all the dimension or attributes are in the same range. I already told you in the first or second lecture, whenever we are calculating the distance or similarities between the object, let's say this is the age attribute, this is the salary attribute. Age, let's think about one person, his age is 30, his salary is 75,000. Another person's age is 25, his salary is 25,000. So what is the range between the age? Age attribute range is 30 minus 25, it is 5. But the range between the salaries, 75,000 minus 25,000, it is equal to 50,000. So if you think about this age attribute and salary attributes, they have different ranges. So it's not suitable things. So we need to normalize the value. Normalize means we can, let's say this attributes 30 to 30 and 25. So we need to convert this age into 0 to 1 range. Similarly, we need to convert this salary into 0 to 1 range. That is the way we can call normalizations. So what will happen whenever we are changing all the parameters into the same range? There is no issue now. But if you think about without normalize the attribute, it will give the long distance. So how you can calculate the distance here? This distance is 50,000. This distance is 5. So you need to apply the Pythagoras theorem and you need to find out the distance. A squared plus B squared is equal to C squared. Let's say it's A, the distance. It's B. This is C. So you need to multiply the distance by themselves and you need to multiply the distance of B themselves and multiple by C squared. Did you heard about Pythagoras theorem? For that, it is a 90-degree angle. It's very, very important. This is Pythagoras theorem. So why I am saying whenever you are find out the similarities, you need to check. Where you can check whenever you do the pre-processing, definitely you will arrange or reset the values, whether it's a high distance value, you need to normalize the values into 0 to 1 range, rescale the values. We will discuss in the pre-processing step. So whenever we are converting into 0 to 1 range, it's very easy. to calculate the similarities. Now, let's think about, we have two objects. We have one object here, another object here. This one is X, this one is Y. So if the similarities between X and Y is equal to 1 means both are equal. If the similarities between X and Y is 1, then they are equal. If the similarities between X and Y is equal to 0 means it's not equal objects. They are totally different objects. So the similarities are comes between the 0 to 1 range. If the similarities between 0.5, they are not exactly same, but they have 50% of similarities between X and Y. That is the way we are considered whenever we are look at the similarities. Next, we will look at the synthetic similarities and semantic similarities. If it is a synthetic similarities, you are checking the structure of the objects. Let's say we have one object called apple, another object called apple. So whenever you are considering with synthetic similarities, you need to check character by character, whether this A and this A are equal. No, but others are equal. So that is called synthetic similarities. Synthetic similarities means we are one-to-one matching. Each character one-to-one matching we are doing, whether both characters are same or different. Whenever we are doing one-to-one matching, we can call as a synthetic similarities. We are look at the structure. Let's think about here the similarities between the two objects, vehicle and vehicle. The similarity is 1. Why we can call the similarity is 1? We will check the V and V, E and V. We will check one by one character, character by character. So both are exactly same. So we are putting the similarities 1. What will happen whenever we look at the similarities between one vehicle and car? This is not same. This is not same. This is also not same. So it is the similarities between them are 0. If you think about the semantic similarities, we are look at the meaning of these two objects, not the structure. We are look at the meaning of two objects. Likeliness of their meaning or the semantic contents. Let's think about the synonyms. Synonyms, they have different words, but they have same meaning. Did you remember what we had discussed yesterday? Synonyms. Do you remember that? Whenever we are look at the word properties, we discuss the synonyms. The singer and vocalist, they are, what will happen whenever we apply the whenever we apply the synthetic similarities, they are totally different. But whenever you are look at the semantic similarities, both are equally same, because whenever we are look at the semantic similarities, we are considering the meaning, not the characters by one-to-one matching. Do you have any doubts up to now? Hello.
No, sir.
Oh, okay. Whenever we are asking you to find out the synthetic similarities, you need to check the structure of two words. But whenever we are asking you to find out the similarities in semantic similarities, you need to find out the meaning, whether they have same meaning or not. That is the way you can find out the similarities. Let's look at some distance calculation methods for similarity calculations. Whenever I already told you, whenever we are calculating the similarities means we find out the distance between the objects, not only two objects. If you think about our data set have 50 data rows or 50 different student data, then we are calculating the distance. Let's say student 1, student 2, student 3, likewise it will go. So you need to find out the distance between the student 1 and student 2, student 1 and 3, student 1 and 4, student 1 and 5, 6. Likewise, you need to calculate the distance between all the objects. Likewise, we will do. for your understanding and easy explanation purposes, we are look at only two objects, but we are look at n number of objects whenever we are calculating the distance between the objects. One of the important distance calculation mechanism is Euclidean distance. Did you heard about Euclidean distance? Euclidean distance means the shortest distance between the two objects. This is the shortest distance among the two objects. Let's say we have an object 1 here, we have an object 2 here. We can calculate, we to achieve these two, we can go likewise and likewise, it will achieve this. This is this entire line, all the distance. But if it is a Euclidean distance, it is the shortest distance. So we are directly connect to lines. That is the way we will find out. So now what will happen? This is the shortest distance between the two objects. That is called Euclidean distance. If what will happen, the shortest distance between the two objects is now 5 meter. After few minutes, 4 meter. After few minutes, 3 meter. What will happen this time? Let's say initially the distance is 5 meter between the two objects. Then it is 4 meter. It is 2 meter. Finally, it's 0 meter. What will happen? Previously, the distance is very high, so they are low similar objects. After some times, they will move close to each others. Then their similarities increases. If the similarities between the two objects are 0, sorry, the distance between the two objects are 0, they are both highly similarities. There is no dissimilarities between the two objects. If it is 0 means the distance between the two objects 0 means both objects are identical. Both objects are equal. Okay, now we will look at how we will calculate the Euclidean distance between the two objects. Let's think about previous example. We have two data sets, height and weight. Student 1, his height is 1.5. Let's say for your easy understanding, it's 2 meter and his weight is 10 kilograms. Student 2, his height is, let's think about this one is 1 meter. Student 2, his height is 2 meter and his weight is 20 kilograms. So if it is a Euclidean distance, this direct line, the distance between these two points are called as a Euclidean distance. How we will calculate the Euclidean distance? You need to find out this distance and this distance. This is a 90-degree angle. So what is the distance? 20 minus 10, 10. What is the distance here? 2 minus 1, 1. So to calculate this distance x is equal to 10 to the power 2 plus 1 to the power 2. Whole thing square root. What is that? 10 into 10, 100. 1 into 1, 101 square root. So that is called the distance. It is equal to 10.01 meter like that. 10.1. This is the distance or similarity between these two objects. If we have 3 attributes, let's say we are including his salary attribute also. Now what will happen? We need to calculate. Let's say student 1 have height h1, weight w1, salary s1, st1. Similarly, here student 2 h2, w2 and s2. To calculate the similarities or Euclidean distance between two students, how we will calculate? You need to put square root. Then you need to find out the distance between. You need to find out the distance between h1 and h2. What is that? h1 minus h2 whole thing square plus w1 minus w2 whole thing square plus s1 minus s2 whole thing square. This is the way you can calculate the Euclidean distance. Did you understand what I'm saying? If it is n attributes, it will continue until n attributes. Did you understand? Okay, let's think about student A. His salary is 3. Okay, let's think about these are 3 attributes: salary, and okay, this one is number of houses, this one is age. Similarly, is this one salary, number of houses, and age. So how you can calculate the distance, Euclidean distance? Euclidean distance DAB is equal to, you need to put square root of distance between these two. What is that? 3 minus 5 whole thing square plus 0 minus 2 whole thing square plus 1 minus 0 whole thing square. What is that? 3 minus 2 minus 2 minus 2 to the power 2, 4. 4 plus 0 minus 2 minus 2 to the power 2, 4 plus 1 whole thing square root 9. Square root of 9 is equal to 3. This is the way you can calculate the Euclidean distance. If you think about the Manhattan distance, it's different things. In Euclidean distance, we will calculate the shortest distance. But if you think about the Manhattan distance, you will go from here to here and here to here this way. So this total distance considered as a Manhattan distance. I will show you an example. Let's think about the same example here. Whenever you need to calculate the Manhattan distance, what you need to do here, you need to calculate mod of the distance between these two. What is the distance between these two? 3 minus 5. Mod, if you put mod, we will remove that. If the value is minus 2, mod of minus 2 is equal to 2. Mod of 2 also is equal to 2. So plus 0, mod of 0 minus 2 plus mod of 1 minus 0. So altogether 3 minus 5 is equal to minus 2. Mod of minus 2 is equal to 2. Plus here also minus 2. Minus 2. Mod of minus 2 is equal to 2. Plus 1. So hold the sum of 3 attributes is equal to 5. So this 5 is called Manhattan distance. If you calculate the Euclidean distance, that is the shortest distance. What is the value we calculate by using this Euclidean distance? 3. But what will happen whenever calculate the Manhattan distance? It's 5. Manhattan distance means we are calculating only the distance between the two attributes by using the mod values. So look at this example here. Just 3 minus 5 minus 2, mod of minus 2 is equal to 2. 0 minus 2 is equal to minus 2. Mod of minus 2 is equal to 2. 1 minus 0 is 0. Mod of 1 is equal to 1. So altogether 5. That is the way we can calculate the Manhattan distance. If you think about the cosine similarities, let's think about one object is there, another one object is there. How long, what is the degree they will, what is the degree they will move by each other? Let's think about this angle called the similarities. How many angle, how many degrees? Let's say it's a 30 degree. If it is a 30 degree, they have distance. That is called cosine similarities. In cosine similarities, we are calculating the angle between two objects. Let's say one object is there. This is a diagram. Okay, one object is there, S1. Another object is S2. So whenever you need to plot from here to here, plot from here to here, this angle called the cosine similarity distances. To calculate the cosine similarities, you need to find out similarities A and B is equal to cos theta. Is equal to, you need to find out the cost product of A and B. A into B divided by mod of A into mod of B. You don't need to do the calculations. Just understand, if it is a cosine similarities, we are calculate the similarities by using the angle value between the two objects. if the angle is 0, let's say both are one object is, let's think about here, this one object is there, another one object is there. So what is the angle different? Object 1 is here, object 2 is here. The angle different is 0. So they are called in cosine similarities. They are exactly same objects, similar objects. Why we are saying that the angle difference between the object is the angle difference between the two objects is 0. That's why we are calling as a cosine similarities. Okay. Do you have any doubts? Last one is jacket similarities. We are apply the jacket similarities only for the set of objects, only not for single object. We apply jacket similarities for set of objects. Let's think about, we have two sets. Set A contains 3 objects, S1, S2, S3. Set B contains 5 objects. So we need to calculate the similarities between this set and this set. At the time, we are using jacket similarities. I will show you with an example. For that, you need to memorize this equation. To calculate the jacket similarities, you need to find out the intersections between A and B. Similarly, union between A and B. I think you learned those things in the set theories. Am I correct? If it is an intersection, mean we will look at for common things for two sets. If it is an intersection, we will calculate all the things. If it is duplicate the things again, we will remove one. Let's say set A contain 1, 2, and 3. Set B contain 1, 4, and 5. What is A intersection B? What is the common thing is 1. So that is called intersections. What are the A union B? 1, 2, 3, 4, 5. This is called union. Likewise, we need to find out the jacket similarities. We are divide intersection by union. That is called jacket similarities. Whenever you look at this example, this set A contains these animals. So to calculate the cardinality, we are write mode of A. We can put the two direct lines inside. We will put the set letter. It will call the cardinality. Cardinality means how many objects are there. In set A, there are 4 objects. If you think about the cardinality of B, it is 5. This is, we are calculating the cardinalities. Let's say this is my first set. This is my second set. So I need to find out this is my first set. This is my second set. So you need to find out the A union B. A union B means this one come, 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 this one come. This one is already there, so not coming here. This one is also not coming. So we will write all these together into one set. That is called A union B. It contains 1, 2, 3, 4, 5, 6, 7 elements. Am I correct? 2, 4, 6, 7 elements. If you think about the union A intersections B, this is A union B. A intersection B, what is the common thing for both two sets? What is the common thing for both two sets? This one is common. This one is common. So how many things are common? Only 2 things. So we need to put these 2 in the intersections. This is the union. I think you already learned the set theories in the mathematical subjects. So whenever you need to calculate the jacket similarities, first of all, you need to find out the cardinality of intersection. Cardinality of intersection is 2. Then divided by the cardinality of union. Union is 7. 1, 2, 3, 4, 5, 6, 7. So that is called 2 over 7 is called the jacket similarities. This is an example. Let's say we have 3 sets, set 1, set 2, set 3. Among them, you need to calculate this. D says indicate the black. This D says the orange. So you first of all, you need to find out the similarities between these two. What is the similarities? What is the intersections? This apple. Is there anything else? No, only one intersection. So one intersection divided by the union. Union is 1, 2, 3, 4, 5, 6. Because the apple again duplicate. So we will remove 1. So only 6 is there. 1 over 6 we can call Jaccard similarity between these two. If you calculate the Jaccard similarities between these two, what is the common thing here? Banana and orange. So intersection is 2. 2 divided by total how many? 1, 2, 3, 4, 5. Because these two are already there. So 2 divided by 5 is called Jaccard similarity between this one and this one. If you calculate the Jaccard similarities between these two, what is the common thing for here? There is no common thing. So the intersections between these two are 0. Then divided by total 6. So total is 0. That is called Jaccard similarities. This is the way we can calculate the Jaccard similarities. Do you have any doubts up to now?